Hi, how's it going? Transmission from the edge. I'm super sick at the moment, but I am still able to code, so I've just been mucking around with some little experiments. I just want to present some results. So here we have my favorite test scene, which you guys must be sick of by now. It's just a whole bunch of spheres, and currently this is running at just under 60 frames per second, which is pretty good given the amount of data that the GPU is crunching. If I look up, because I have an acceleration structure, it increases a little bit to 90 frames per second. That's pretty cool. And the topic of this little presentation is the importance of the computer hardware. Contrast that with the following scenario. So here we have a ray tracer, and it's doing exactly the same stuff. The only difference is that when we go and dispatch the scene for rendering, we dispatch subgroups of 8 by 8. You've probably seen this in a previous video, but I just wanted to include this to show the dramatic speed up. So here we have the same result, and we're rendering at about 10 times the speed. 500 and something, 600 frames per second. So that's pretty good. We can look up again, and due to the acceleration structure, we now have less things, and so our speed increases to 1000 frames per second. This is pretty cool, but it turns out we can actually do better. So what I'm doing at the moment is I'm passing over a whole bunch of data in images. I'm encoding the little floats and things in the pixels of the images. And then I have some functions down below, which will basically sample the images, take out the information, and we've got our stuff. This is very nice. But there is something a little bit off about using images, because images are size limited, and simply put, there's a better way. Now, the stages of this progress were sort of completed, at home in a fever. So I hope you can appreciate that it's a little hard to demonstrate this going back over the steps that I took. But basically what we can do is we can make storage buffers, which are simply limited to whatever the GPU can handle. Here we have a storage buffer. It's an array of spheres. We have an array of nodes and sphere indices. Okay, great. Now, if we were to implement this naively, we would actually degrade our performance quite a bit. And it turns out that as a middle ground, images are quite good because their size is fixed and everything. And then when you have a storage buffer, by default, that's sort of a completely dynamic memory type, which means every time you read to the memory, every time you write to the memory, there's a bunch of little background checks which happen, and those background checks really stack up. So what we can do, the one thing we can do is if we go to this buffer object, it's this line here. Instead of, typically this would be GL buffer data. If I do this will kill my performance. This is horrible. Instead, we use GL buffer storage to basically declare the data as immutable, simply meaning it's fixed and there's less checks and balances. And then when we come to actually update it, we call GL buffer subdata, and that updates a subregion of the thing. It doesn't change the original memory or its layout or anything. By default, GL buffer data will sort of rewrite the memory, even if it's rewriting the same memory. So just to run this, I've given enough lead up to this, I think. So remember, we went from 60 frames per second to about 600. And currently, this is about almost 2,800 frames per second. What a difference. Wow. And if we look up, we got less stuff. So we get up to 4,600 frames per second from 100 frames per second. That's just blown me away. It's very cool. And yeah, so I guess I just wanted to present this. I think it's very cool, and the point is, no matter which level you're programming at, being aware of what's going on in the underlying hardware, even though it's not always well documented, like it makes a massive difference. The other thing, okay, this is getting a little rambly now, so I'll probably close it off soon, but if we were to go to the color buffer that we're working with, again, instead of using, GL text data or something, I'm using GL text storage, which is doing the same thing as buffer storage. It's allocating an immutable chunk of memory, which means there's less overhead to access and, to work with the memory. And if we were to update it, we could use subimage, and that works the same way. Anyway, that'll be it for now. I'm hitting the wall, but yeah, have a great one, and I will really focus on recovery now. All right, bye.